Let's practice graphing another one. So this time we're given that f of x is equal to negative times the quantity of x plus 3 squared. We can identify our vertex. I see that I have a plus 3 in the parentheses, so remember that that means that's a minus 3 for my x value. I don't have anything tacked on the end, so this is like a y value of 0. We haven't moved from the original y location. Transformations, let's identify those. So the first thing that I see that's different from my parent function is I see a negative sign out in front. Remember that a negative sign means that we have reflected in the x-axis. And then the other thing I see is this plus 3. And remember that a plus 3 that we see is actually going to shift us to the left. So we are moving left by 3. Now I want to go ahead and graph this quadratic. I'm going to approach it the same way as I did before, setting up an XY graph with some room in the middle to show some work and work out the values. I'm again going to start with my value of negative 3, and I know that that's 0. I'm not going to prove it to you this time with the work, but we have seen before that it does work out on the last problem. If I have negative 3, again, I'm going to move to the right just to stay consistent. And so my next value will be negative 2. And so I want to plug a value of negative 2 into this equation. And so everywhere that I see x, I'm going to plug in a negative 2. So I'm going to say negative times a negative 2 plus 3 squared. And if I simplify what's in parentheses, negative 2 plus 3 is going to give me a positive 1. So this is a positive 1 squared, but then tack a negative onto it. So my final value is a negative 1. And then moving to the right again, we'll plot negative 1. And so I will plug a negative 1 in everywhere that I see x in the equation. And that gives me negative, and then in parentheses, I'm going to have a 2 squared. 2 squared is 4. Put a negative on it is negative 4. Let's go ahead and plot this and then use our axis of symmetry to finish out the left side. I'm going to plot the point 3, 0, negative 2, negative 1, and negative 1, negative 4. My axis of symmetry has to go through the vertex, so it's here at negative 3. That is my AOS, axis of symmetry. And I can plot the right side of my graph to look like this. If I go along the axis of symmetry, when I go down 1, I am over to the left 1. And when I'm down 4, I'm over to the left by 2. And so I can use those points to fill in the rest of my graph. Problem number 3, I'd like for you to pause the video and try this one on your own and then see what you get and compare your answer to mine when you come back. Welcome back. Hopefully you were able to discover that the vertex is at 1, negative 3, based on having a negative 1 here. Remember, it's the opposite of what you see because of the negative built in the equation. And then my y value is a negative 3. The negative 1 inside the parentheses is going to move me to the right by 1. And the negative 3 tacked onto the end is moving me down by 3. I'm going to start with my vertex as my first point down here. So at 1, I know I have negative 3. Don't really need to prove that by showing the work, but you could have if you wanted to. Moving to the right, 1 unit, I'm going to plot 2 next. And working through the numbers of putting a 2 into my original equation, I'm going to get a negative 2. And then finally, my third point at 3, when I plug those numbers in, I'm going to get a 1. So plotting those 3 points, 1, negative 3, 2, negative 2, and 3, 1, I'm able to fill in the right side of my graph. I identify my axis of symmetry as being the line right there at 1 that goes through my vertex, and so I can use that line to reflect and create the left side of my symmetric graph.